I just got a spam call, so where was I? I realize that when calls come in, I'm sure there's a way to turn those off while I'm filming, but I haven't figured that out yet. So here, we'll continue. Critical numbers, where the derivative is 0 or undefined. Local extrema, that's local maximum or local minimum. And the plural of maximum, minimum is maxima or minima in the math world. You can also say maximums and minimums. Local extrema, that's saying everything at once, occur at the critical numbers. So now it says if the function is defined at the critical number and the function changes from increasing to decreasing at the critical number, then the function has a local maximum at that critical value. I'll use that interchangeably in a critical number or critical value. If the function is defined at the critical number and the function changes from decreasing to increasing at the critical number, then the function has a local minimum. Now let me show you the picture I drew of that. So what we have here, local maximum. If the function is increasing and then goes to decreasing, we have a critical number here, and that's called the local maximum, increasing to decreasing. And remember, increasing means f prime of x is greater than 0, and decreasing means f prime of x is less than 0. Now a local minimum, if the function goes from decreasing to increasing, then we have a local minimum, and that's a critical number, and this is f prime of x is less than 0 and f prime of x is greater than 0. So what we're going to be doing here is taking a function, so I give you some kind of function, and you're going to analyze it for where it's increasing or decreasing using calculus, and then we'll find all local extrema. So the first function is just a little polynomial. You even know that that's a quadratic, and that's a graph of a parabola. And then we'll do a 4th degree polynomial. Then we'll do a quotient or a rational function. And we'll do a little application here. I should have written R and C are in dollars, but I didn't, so put that in there now. So the first one I'm going to do is this one. All right. We're doing a first derivative analysis. So let's take the derivative of that. So take the derivative. What do you get? That's right. It says find the critical numbers where f prime of x is 0 or does not exist. And so taking the derivative, you get negative 2x plus 8. And we set that equal to 0. Solve, right? Subtract 8, divide by negative 2, and you get x equals positive 4. So that is just taking the derivative and setting it equal to 0 and solving. And this is called a critical number, right here, or critical value, critical number. And what I do is I come over here, and I'll ignore all this, I put a number line up. So I've got a number line here, and I name that number line f prime of x. So what I'd like you to do is not, there's a lot going on. I'm planning ahead here, and maybe I shouldn't have written all this on top of it, but what you want to do is just have a number line that looks like this. It's totally empty. Put f prime of x beside it because we're going to do a second derivative analysis later. And at some point you're going to wonder, are we talking about f prime, or f double prime? So in this case, we're looking at f prime of x. All right, so I even put negative 2x plus 8 beside it. So this is where the derivative is 0. We set that to 0 and we found 4, so we put that critical number on this number line. Now what we're going to do is test points before and after that critical number to see if that derivative is positive or negative. So let's come down here, and I wrote test values between the critical values to find the sign of f prime. Because positive means increasing and negative means decreasing. So I took the derivative, or I took a value to the left of 4, and I am choosing x equals 0, even though it says something else there. That's to the left of 4, right? I'm going to pick a 0. And f prime of 0, I plug that in here, and I got 8, which is positive. Then I'm going to try a value after the 4. Something on this interval. You got a lot to pick from. I just picked 5. Oh, I've got these. I forgot to fix these. So I test x equal 5 on this interval. F prime of 5 is negative 2 times 5 plus 8, and I got a negative value. So I'm getting a positive value on the one side of the critical value and a negative value on the other. And what I've done here then, if I come above, I see that I put a plus here because I got a positive with that value, and I put a negative with that value. And now I'm going to interpret it, and that's what I haven't read. If you get a plus here, your f is increasing. If you get a negative, your f is decreasing. Okay, so I can come over here and say, well, not yet. Now, the other thing to observe is if the function increases and then decreases, so I drew kind of a little sketch of what this might look like, you get a local, well, it's a maximum, that's a high point. So what you're going to do is conclude after that. Here's the conclusion. F is increasing on negative infinity to, hold on, I'm looking at the wrong problem. Try again. Conclusion of this one. That f is increasing on that interval from negative infinity to 4. F is decreasing on 4 to infinity. And f has a local maximum at 4, comma 16. Now that 16 came from plugging it back into the original function. So I took the 4, put it in here, and I got 16. And that's what we're going to be doing. We're going to find out. I'm going to give you a different function. You're going to find out where it's increasing, decreasing, and if there's a local max or a min. This one only had a local max. All right, I'll be back.